Hello everyone and welcome to my channel, and today I'm going to solve this limit question. I'm actually not going to only solve it, but I'm going to talk about the mystery behind of this problem. I would say 99% of students would not know the reason in behind of this answer. Most of them would know the answer, but I would say 99% of the students would not know the reasoning behind of this answer, and even some teachers or even profs would not know the answer as well. So let's write down the question once again. When we have limit questions, the very first thing for all of the questions is that you should replace the value. But what is the value? The value in here is x's adjacent to 0. But what does that mean? What does that x close to 0 mean? It basically means that your x's are not exactly 0, but they are very close to 0. So x adjacent to 0 can be either of these cases. It can be a positive value like this, or a negative value like that, right? But it cannot be exactly the 0. So by knowing this, let's replace x0 to our question. The answer would be sine of 0 over 0, sine of 0 equals 0. So we will get to this as the answer. This cannot be an answer. Whenever you got to this 0 over 0, more than, I would not say 100%, more than 99%, the answer is something else, right? So this is not the answer. You cannot leave the question as this. So again, back to the beginning. I want to let you know a rule that you can use for this limit and the similar limits, L'Hopital rule. But what is this rule and when can we use it? Whenever in limit questions you got to 0 over 0, you can apply this rule. So again, whenever you got to this 0 over 0, you can apply this L'Hopital rule. But what is it saying? The L'Hopital rule says that when you got to 0 over 0, you can apply and find the derivative of the sine x in here, or anything that was here, and the derivative of the x as well. So after finding the derivative of the numerator and the denominator, so you have to find the derivative of numerator and the denominator whenever you got to 0 over 0. That's the L'Hopital rule. Then you can once again apply the x0 and see if you're getting to any answers. So let's do that. Cosine of 0 is 1, so it would be 1 over 1. The answer would be 1, correct? So by using the L'Hopital rule, we found that the answer for sine x over x would be equal to 1. But let's write the L'Hopital rule once again. But why? Like a lot of you might just memorize the L'Hopital rule, but you do not know the reasoning behind. So to know the reasoning behind, I have to graph the numerator and the denominator. So this would be the sine x from +1 to -1. This is y, this is x, y equals to sine x. And we have the denominator, which is y equal to x. So we are talking about x's adjacent or close to 0, right? So the rest of the graph is not helpful for me, right? Like these parts are not helpful at all because we are talking about x's very close to 0, like here and here. So we should zoom in to this part and see what is going on. So if we zoom in to this part, again it is y equals sine x. We will get to something like a line, correct? So if you zoom in, if you really zoom in, you will get to something like a line. So again, we are very close to 0. It's the value in here is something like 0, 0, 0.0000, a lot of zeros, and then a 1. Or here is a negative value. So we are very close to 0 and we have zoomed in to this part. We will do the same thing for y equals to x. And we see that we are sort of having the same thing as before. But let's check if these two graphs are actually overlaid on each other or not, or what is basically happening. So we have y equals to sine x, and again we are only talking about x is very close to 0. So again, this was a line, right? When you zoom in very closely and you look at points very close to 0, you will only see a line. You would not see something like this anymore. You would, if you zoom in, this would be just a line. So to have a line, we have this equation, y equals to mx plus a. We do know what the a is. Why? Because we have a point in here which is 0 and 0, right? So the a is 0 for sure. But we do not know the tangent line, or we do not know the m. So let's find the tangent line, or m, for sine x. To find the tangent line, you have to find the derivative of sine x. What is the derivative of sine x? It is cosine x, right? And when your x's are close to 0, your tangent line would be equal to 1. So your m is equal to 1. So your line, which was something like this, we know the m right now. So it would be y equals to x plus a. Our a is 0. But some of you might be like, why a is equal to 0? Let's have a closer look. The only point that we do know exists is 0 and 0, right? So let's replace y equals to 0 in this line. Let's replace our point. Y equals to 0, equals x, which is 0 again, plus a, right? So a would be 0 as well. So your y would be equal to x for sine x, x very close to 0. Your sine x would be like changed to this equation. So again, what was the limit? The limit was this, right? So you have sine x when x's are very close to 0. You know that when you are very close to 0, your sine, you can write your sine x in another, like using another equation that we just found out, y equals to x. So let's do this. Your x's goes away. You will get to 1 as the answer. So the L'Hopital rule is basically saying that when you zoom into any graphs, you will get to a line, to any graph. It can be cosine, it can be tangent, it can be sine, it can be anything, right? When you are very close to like 0 in here or here, you will only see a line. So if I zoom into here, this would be the line for cosine, right? If I zoom in here, this would be what I can get, right? So the L'Hopital rule is saying that if you zoom into that exact point, you will get to a line. Doesn't matter what your equation, how complex your equation is. You will get to a line exactly at that point and at the adjacent points. And by finding the tangent line or the M, you can replace the new equation that you find for your function, like for sine x, it was x. I replaced x and I could find the answer. If it was cosine x, it would be the same as well. So thanks for watching the video, and please leave a comment if you have any questions, and I would appreciate if you could subscribe to my channel. I will try to answer your questions in the comments, like the comment bars. But if I couldn't do that in the comment bar, I would try to record another video to make sure that every one of you is doing good and like none of you have any questions. Thank you very much.